Nothing like going live on a Sunday morning after taking a day off streaming and finding out what settings have to be reset. Hopefully everything's up and running now. And we got a working stream, and I'm going to switch over to my desktop here. If I can figure out where the button is. There we go. Today we're going to work on Advent of Code days 18 and 19. I had finished 17 on Friday, and then I wasn't able to stream yesterday, but we got 18 and 19 available to us. I try to avoid spoilers, but I was told through friends that 18 involves exploding binary trees somehow, and I haven't talked to anybody about 19. So let's go over to AOC 2021 and start setting things up. First thing we do is add our new code, day 18, and put it up here, right there, and then we try to check, and it doesn't check. Make dir source day 18 mod day source day day 18 mod rs. And check should check, and run should run. What do I do? Run. Go. And it panicked. Did I forget to save my main? No. Oh, because today's the 19th. That's what's broken. All right, we're gonna temporarily change this to -2. Okay, try again. There we go, day 18. I'll have to remember to switch it to -1 again after we get day 18 done, he says hubristically. All right, so let's dive right in. Let's see what day 18 has in store for us. Snailfish. You descend into the ocean trench and encounter some snailfish. They say they saw the sleigh keys. Oh, okay. So we're on the right trail. We only have a week left, so better find them soon. They'll even tell you which direction the keys went if you help one of the smaller snailfish with his math homework. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is a pair, an ordered list of 2 elements. Each element of the pair can be either a regular number or another pair. Pairs are written as x comma y, where x and y are the elements within the pair. Here's some example snailfish numbers. 1 snailfish number per line. Okay. Very nice snailfish numbers. I can see what my friend meant by binary trees, as it certainly looks like a binary tree. I know that binary trees this is binary heap. I saw the binary in there. I said, oh, did I already look for that? No. Binary trees in Rust are problematic because of the you can't really reference. You'd have to either like box it or reference count it or something like that. You can't create a struct, num u32 and then left struct node, left node, right node. And then if you can't do this because then the structure contains itself, right? So it won't build. So in other languages you just make these pointers, but then once you introduce pointers, then you have to introduce lifetimes. So you expected to name lifetime parameter, and then things go downhill from there. So we might want to. I did add a lifetime. See, this is where I get everything wrong. Expected to name lifetime parameter. I put the freaking okay, so it probably wants it here. Yeah. Does that mean I can remove it from here? No. So you need it in both places. And then it'll compile. But then things get really messy because then things get reference, and then you try to add a thing and then it says it goes out of scope. And so I haven't learned the right way to do it. I haven't learned the right pattern to do it in Rust. And that's something I need to learn, but That's going to be an off-stream thing, not an on-stream thing. Okay, so we're not going to do it using this, is the bottom line. This snailfish homework is about addition. To add two snailfish numbers, form a pair from the left and right parameters of the addition operator. For example, 1, 2 plus 3, 4, 5 becomes 1, 2, 3, 4, 5. Okay, there's only one problem. Snailfish numbers must always be reduced. And the process of adding two snailfish numbers can result in snailfish numbers that need to be reduced. Okay, to reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. Okay, that's where the exploding binary trees comes from. Okay. If any regular number is 10 or greater, then the leftmost such regular number splits. Once no action in the above list applies, the snailfish number is reduced. All right, this is all highlighted, so I'm going to reread this so I understand what's going on here. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs. Okay, I think I understand this part. The leftmost pair explodes. I don't know what exploding means yet, but I know what nesting is. Like this is nested inside 4, but right? 1, 2, 3, 4. Oh, if any pair is nested inside 4. So there has to be a 5th level. Okay, then it explodes. Then you have to repeatedly do the first action. So just making sure I understand this. We explode a pair, and then we check again to explode a pair, and then check again to explode a pair. And every time we explode a pair, we have to check again for more explosions. So I guess explosions can cascade. And then after we're done exploding everything, then we want to split. And if we split, then we have to check for an explosion before we split again, right? Because we always repeatedly do the first action. I think that's the way this works. Okay, so once no action in the above list applies, the snailfish number is reduced. During reduction, at most one action applies, after which the process returns to the top of the list of actions. Okay, so this is repeating this here. Repeatedly do the first action, you got to return to the top of the list of actions. For example, if split produces a pair that meets the explode criteria, that pair explodes before other splits occur. Okay. To explode a pair's left value is added to the first regular number to the left of the exploding pair. And the pair's right value is added to the first regular number to the right of the exploding pair. What? Pair's left value is added to the first regular number to the left of the exploding pair. Oh. So for exploding 9, 8, yeah, see it's in 5 brackets. We got 5, 1, 2, 3, 4, 5, and then a 9, 8. So this needs to explode. Okay. The pair's left value, in this case is 9, is added to the first regular number to the left of the exploding pair, if any. So there isn't any, so we don't do anything. The pair's right value, which is 8, is added to the first regular number to the right of the exploding pair, if any. So that goes here. So 8 and 1 gets 9. Exploding pairs will always consist of 2 regular numbers. All right, that simplifies the code a bit. Then the entire exploding pair is replaced with the regular number 0. So this 9, 8, 1, 2, 3, 4 becomes 0, 9, 2, 3, 4, right? So the 8 goes to the 1, and then the 0, what's the 0 for? Oh, that's right. That's the thing I just read. The entire exploding pair is replaced with the regular number 0. Okay. So 3, 2, the 3 goes into the 4, and the 2 goes nowhere, and this whole thing becomes 0. So then this is 7 and 0, which is what they're showing here. Okay. I think I understand explosion. We still don't know how to structure this data, but we know how to explode the data. To split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down, while the right element of the pair should be the regular number divided by 2 and rounded up. For example, 10 becomes 5, 5, 11 becomes 5, 6. All right. Once no reduce actions apply, the snailfish number that remains is the actual result of the addition operation. All right, so here's where we split, right? I see a 15, and the 15 splits into the 7, 8 pair. Right? And, oh, so this doesn't explode here. This doesn't explode here, right, for this line. The 8, 4 explodes into this 15 and 13, because the 8 goes into the 7, and the 4 goes into the 9. The split that happens on the 15, because I guess there's nothing left to explode. And then we check for an explode again, and there's no explode, so we do the split. And now that we've done a split, we do an explode. Okay. Once no reduce action applies, the snailfish number that remains is the actual result of the addition operation, and I'm not going to read that out loud. The homework assignment involves adding up a list of snailfish numbers, your puzzle input. The snailfish numbers are each listed on separate line. Add the first snailfish number to the second, then add that result to the third, and so on. Okay. Here's a larger example. Oh, and they go step by step so you can see exactly where you fail when you write your code. To check whether it's the right answer, the snailfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. The magnitude of a regular number is just that number. For example, the magnitude of 9, 1 is 3 times 9 plus 2 times 1 equals 29. And then we have a bunch of things for testing magnitudes. Okay. So given this example homework assignment, the final sum is this. And the magnitude is this. And they want to know the magnitude of the final sum. Right, so how do we represent this? And like I said, I don't want to use a binary tree in Rust because I haven't learned how to do it yet well enough to do it on stream without struggling for 3 hours. So because we're just going back and forth, right, we have to go, this 8 has to search forward for the next number, and this 9 has to search backwards for the next number. Maybe we just use a queue. And that way we don't have to care about nesting or anything like that, going up and down binary trees. We can just walk forward and explode, or walk backward to explode. And then splitting should be also pretty straightforward. All we need to do is insert the new pair wherever we are in the queue. And it'll just be a circular queue. I think that might be the most straightforward way to implement it. It might not be the fastest, but it'll be straightforward. All right, so let's first take a look at our input. I assume it just looks like, I think, okay, there's not too many. I should also probably check to see, what's this, day 18 still. Let's move it into place. Let me just take a look at it real quick. 18. And I just want to see if there's any. Okay. So everything in here is a single digit. So that makes the parsing easier. It also means that these are all probably reduced. Checking to see if there's anything to explode here is harder than checking to see if things need to be split. But let's assume that the input is completely reduced. I don't see, nothing stands out really as having lots of open brackets. All right. So that means we don't have to worry about reducing it before we start doing the work, or having an input that's too nested. because all we're doing is adding one at a time. So if adding one results in explosions, then we'll do the explosion right there, reduce everything before we get to the next step. And I think that's what they're showing here with this example. We take the 045 blah blah blah, we take this 737, so on and so forth, and then we convert it to this. And this is clearly modified from this original data, right? So this must have been reduced before adding it to the next one. Did they say to do that? Add the first to the second, and then add the result to the third. It doesn't say to reduce it before doing it, but that's what I'm seeing here. So let's write a quick parser to parse. Actually, what we're going to do is take test input. This is our test input, and input test 1 day 18.txt. I'll paste that in there, and this is use crate details read file let data, or I think I say lines, right? Read file inputs test 1 day 18.txt. Okay, so we're just looking at this stuff here. So if we're going to use a queue, we want to create a list of all of the So let's create a queue of tokens then. Let's create an enum which has our tokens. Call it talk for token. It can be a left bracket, it could be a right bracket, or it could be a number, and these are all going to be U8s, right? We don't go negative because all we do is we either divide by 2 when we do the split, or we add single digits to single digits, which only will go as high as 18. Hi, Shirk Shack. How are you? And then, so what we can do is now just go line by line and parse out all these things. So do I want to write a parse function, or just do it here for L in lines, or C in L.chars? This might be the easiest way. Yes, this is the snail exploding problem. So this is a lot of text to read, so I'm guessing the solutions can also be pretty complex. Match C. So either it's going to be a left, in which case we're going to, we need for each line we'll need a new vecdeck. Data equal, mut data. It's going to be a vecdeck of tokens. And so this is just going to be data.pushback left. Token left. And then if it's a right, data.pushback token right. And if it's a number, so 0 dot 9, or dot equals 9, it's going to be data push back token number. And what are we going to say? C as U8 minus B0, all as yeah, that works. And then a comma we ignore. Anything else is panic, bad input. Uh-oh, I messed something up. Oh yeah, I got closing here, okay. So, yep, now it works. Okay, good. So I should now be able to print out one line looks like this of data. And I need to derive debug. to do that. Oh, do I need to, is that standard utils? Standard collections, maybe? Yeah, okay, so that worked. Let's see if it runs. It did something. We got a left, 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 num0. Then get a left, num4, num5, a right, a left, a 0. Okay, so I think it's parsing. It would be nice if I could print it out in this pretty sort of manner. I don't know if we want to waste time doing that. Maybe we solve it first and then check, or maybe we want it now because it'll be easier to read. Okay. Until then, until we decide we need it, let's create a let's call it numbers. It's just a vec deck of token. Yeah. It should be a colon. There we go. And then we can just push nums.push data. Okay, so now I think we've gotten everything parsed. We want to so the next thing to do we want to check to see, we want to test, right? Let's write some tests. I think that would be a good first step, is trying to test. Where do we have some examples for exploding? Because that's what we need to do. Okay, so let's test this. And that means that I actually want to be able to convert the numbers in my test. So we'll create a test here and explode 1. I want to be able to say let stir equal, not stir, let num equals, let's write a conversion function to do this. And it's just basically these lines here. Pub fun convert. And this is going to return a vec deck of tokens. Like that. And this will say data. And up here, this comes down here. And then we want to say nums.push of convert L. And that we should still have our same thing now. Okay, so if we convert that in our test, let's just print it out. Just make sure that's converting right. Num, and then we'll just assert EQ 1, 2, just to make it blow up. Oh, I need my L stir reference. Tokens declare as private. There we go. So if I run my tests, oh, I forgot the superstar. Always use superstar on your tests. Use superstar. All right. So we got left, 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 9, 8, right, num 1, a right at num 2, a right at num 3, right at num 4, and a right. Okay. So that's working. Do I want to validate that, or do I just want to explode it now, right? Just to test explosions. Do we want to write a function which does explode and then test the explode? We do want to be able to generate. We want to validate the explosion, right? We want to see that we got this. 4 left's a 0, 9. But that's going to be a pain in the butt to write to compare against. So it could be that we just, right, so maybe now is when we want to write something that converts a number into a string, and then we can compare the strings. That way we can say assert EQ num is equal to the string this. Display num. Stringify? Okay, and then I'll just write stringify and give it a num, which is a vec toke. Let's make that a type. Call it snail num. Or just snail. Yeah, snail num is good. And that way I don't have to do that all over the place. Okay. Lowercase m, and then we're going to just return a string. And how do we do this? Let s equals string new for token in number. If commas are going to be a pain, right? Match toke. If it's left, s dot, what's it, s dot append? How do you append to a string? Rust append char to string. Push. It's just called push. Okay. Push this. Top right. So push this way. Top num. S dot push, and it's going to be, oh, this could be multiple, right? I want to say s equals format bang of this and this of s and n. Yeah, we just have left, right, and number. Those are the only three. Okay, and this isn't going to work, right? Oops. Did I forget a... Oh, I have too many of those. There we go. Oh, there should be commas. Otherwise, it won't compile. All right, we got 2 warnings, but that's okay. Let's run the test. Yeah, so we're just missing the commas, but I think we successfully parsed it out. So we can figure out how to put commas in there. We'll be golden. So if we have a number, we don't want to put a comma before the first number, but we always want to put a comma before the second number. But we might have this nesting situation where the second number doesn't come for a while. Maybe there's no easy way to do this. Maybe I just put spaces before numbers and then just not worry about the testing of it. This will just be for printing. Yeah, we can read this even if we can't print it. Because I'll need to, if I want to do this right, then I have to start figuring out what nesting level we're at. All right, so I'm not going to worry about this then. This is just going to be with spaces. And it still didn't work because I'm missing, I'm missing a space here. Before every number is a space. That's the key. Okay. So we're able to stringify it, and now I want to test exploding. So I want to say, do we want to return a new number on explosion? And how do we want to do these? So in order to test explosion, we need to actually walk through all of the numbers. So let's say some fun explode. And we have a num, which is a snail. Actually, we want to modify it, right? We want a mutable reference to a snail number. And it's going to return whether or not the explosion happened. Right? Because we'll modify it in place and then say whether or not we exploded. Because if we exploded, then we have to go check again if we need to explode again. So let's say, I just thought of something. So if I have a vec deck and I'm just rotating through the vec deck, I need to know when I reach the end. So let's create a start marker. And before we do anything, we're going to say vec talk start. And I might have to say from, right? Vec deck from. Yeah, okay. All right, so that way, so the first thing that should be on every queue should be a start. So let's pop that off the front right away. So the marker is going to be num.pop front, unwrap. And if it's not the start, then we want to panic and say we messed up somewhere else in our code. Snail num does not start with start. Okay. Ring buffers are so good. Yeah, ring until you have to worry about whether you reach the end. Because what I'm thinking is I'll just keep working my way forward. I'll pop the front and push the back until I reach an explosion point, right? So now we want to push the marker back. So num.pushback m, right? Because now I'm going to loop. And in this loop, the first thing I'm going to do is pop the front. Match num.pop front unwrap. And we're going to say if it's a left, then, now's when we need nesting levels. So we start at 0, and we'll say nest plus equals 1. And if we've hit 5, then do explode, right? And otherwise, we'll just push the left back. Actually, if I'm going to do that, let's do it this way. And then we'll say just match T. Because that way I can just say num.push back the token that I took off. And that's that. If we hit a right, then we're going to just subtract 1 from nest. And we need to push it back. If it's a number, what do we do? we just push it back, right? We don't care about numbers. We're just looking for nesting. Num.pushback. And if it's the marker, then we've looped around to the end. Or just we've looped around to the start. So we've just popped this off the front. We need to pop it back onto the front to make the number correct. All right, that's an explosion. And now we just have to do the actual work. So what does it take to explode? We've reached a point where we've hit our 5th open bracket. So we're right here where I just highlighted. So we want to grab these two numbers. And then we want to walk backwards to find the previous one, and walk forwards to find the next one. But I don't want to lose my spot. I don't want to lose my spot. So what I think I want to do, I'm trying to think of, because we're right now right here. So what we're going to do is pop off. The left one is going to be, this should be the next one. Num pop front unwrap. This is left token, not the number. We're gonna have to extract the number from it. And then right token is going to be the next number. Unwrap. And then we're going to see the closing bracket. That's what's coming up next. So let's pull that off. And actually we can just verify if num.pop front dot unwrap is not equal to a right bracket, then panic nest is 5 deep and we don't have a right bracket. That's pretty straightforward. You already popped num to get started. I popped the left to get the thing, and then I want to pop the number right after that. So the question was, how can the second? Oh, you already popped num to get the start. So how can the second pop front ever get a token start? I did a pushback right here because I wanted to make sure that the start token was at the back of the queue, so that by the time it got to the front, I'd be able to pick it up here. All right. Yeah, and if you disagree, feel free to shout out, because I'm coding in front of a live studio audience is not easy for me. You didn't see the pushback? Yeah, I kind of snuck it in there because I figured we would need it for this point here. All right, so if this is not a right, then we want to panic, because we ended up coming up with something that's not a number, not a pair of numbers. Now I'm going to assume that we have a number. In right. So we should be able to say we should be able to just destructure this. Right, so now right contains the actual number we want to add, and we want to loop forward. We want to actually iterate forward. Right, we don't want to shift the queue. We just want to look forward until we see the one, because we want to keep where we are right now so that we can go backwards. So what we do is we say for next in num.iterMute, because we want to modify it, right? We're going to add right to whatever number we find. We're going to match on it. And if it's a snail num of n, we want to change next to be a snail, not a snail. What am I doing? Token. Token, a num of n plus our right value. And then we want to break. But we might reach the end, right? So if we have a 2 here, we might come to the end, and that's again where our start marker is going to come into play. This should be an arrow. So if we hit the start marker, then we're just done. And then we have to handle all the other cases. All the other cases we don't care about. We're not modifying the list, so we don't have to push back anything. I think that's all we need to do for going right. The pair's right value is added to the first regular number to the right. The entire exploding pair is replaced with an irregular number 0. Okay, well, yeah, so actually where we are right now in the queue, if we just do a push front, is that all we need to do now? Is say after this if this fails, then we want to panic. Right hand side was not a number. Right? So let's actually put a little commenting in here. Move right hand side number, add right hand side number to next number in the list. Then the next thing is going to replace the current value with 0. So we've already popped the current pair. I should say pair. We've popped the current pair. So that means all we need to do is say num.push front of toke num 0. Okay, so that step's easy. And now we want to rotate the queue. We want to start looking backwards until we hit the start marker again. So if let toke num left equals left token, else panic. Left hand side was not a number. And I think that's all we need to do for explosion once we figure this part out. Yeah, and we can start looking from the back. So we can say let next equals num.pop back unwrap. And we're just looking for a number. So match next. So if it's start, then we're done. Break. If it's a number, n, then we do the same thing we did up above and we just say, oh, we don't have a mutable thing. So we can just do, say, num.pushback token num n plus left. And then break, because we're done. Anything else, we're just going to say num.pushback next. Oh, push front. I was hesitating there because it didn't make sense to push back and then pop back. This we don't care whether we push back or push front because we're just going to break out anyway. So I can just leave that alone. Oops, what did I do? And then we're here, close that, and this is closed. So is this all we need to do for n explode? Does this even compile? It does not. It's empty. Oh, I have an extra thing here. Oh, we need to implement partial equal. What else? That's also partial equal. We can't add that to that. Put a star. You got to put a star somewhere. Oh, U8 can't be dereferenced. Did I put the star here? Yeah, and then I have to do it. Oh, it doesn't like this. Oh, this should be in a loop. What am I doing? We got a loop over this. Thank you, Russ, for catching the fact that I'm breaking out of not a loop. Let's just, I guess we can just say loop forever, because we're going to catch ourselves in the, when we hit the start marker. Oh, and then we probably have to put a star here, maybe? I don't know. Does it tell me to? It does not tell me to. It says I need to do something here. Start is not covered. Oh! Okay, let's get rid of stringify because I'm not using it anyway. Oh no, I am using it. Actually, that's a good thing. We should put in the marker start just to show that what would be a good character for the start of the string. That, comma. And then this becomes greater than. And that way we see that we have the start marker there. All right, we have 3 warnings. Probably because we're not calling explode anywhere. So let's try this. Assert explode num, because it should explode. And then assert eq stringify num, and it should be this plus these guys if we got our explosion correct. Still have 3 warnings. Let's run the test. Expected reference. Oh, expected mutable reference. Means I have to make that mutable. And I hit F1 again. Okay. Oh. Oh, that's a shame. That's a shame. Are we going to run into a whole bunch of problems with this now? I don't want to copy. Oh, the oh, okay, yeah. We won't. I'll just make these references. I don't know why I didn't do that in the first place. It's my Rust beginner. Nest is 5 deep and we don't have a right bracket. Uh-oh. You know, 1, 2, 3, 4, 5, num, right. There is a right there. All right, well, it's a good thing we're testing it. Where did we fail? So we popped the left. Nest greater than or equal to 5, so we want to do the explode. We're going to print left token is going to be this. We're going to print the right token. And we're going to put what we found here. Let right bracket is this. And we're going to say if, stop that, if right bracket is not equal to that, then we're going to print it here, right bracket. And this will be debugging code we take away. So the left is num, and the right is num. Oh, it worked. Oh, it was doing it the second time. It got 2 lefts. It shouldn't be doing it a second time, right? Once we get... Oh, you know what I need to do is after I'm all done and we break out of this, we need to reset. It's possible that after we've done all this mess, we need to move everything back to where it should be. Right, this is my explode. It could be that the marker is not at the front anymore. But this... Okay, so what I'm going to do is just print a thing here. After we finish doing this, we'll say println exploded number, so that I can see that that happened, because it looked like it did. Yeah, and then it's going again, and it should stop after that. So after we explode the number, oh, we just need to break. And then after what I was thinking before, after we need to do is saying while let some token is equal to num dot front, if token is equal to start, then break, else num rotate left by 1. I just want to move the start back to the front here. And I can spell break correctly. B-R-E-A-K. There we go. And, oh, I gotta put a star there. And it doesn't like this. Oh, because I'm not returning a bool. Oh, right. I'm not returning a bool. I need to set a flag. Exploded is true. And then up here, we'll say let mutt exploded is false. And then down here, we'll just return exploded. Okay. Why didn't that fail before? Okay, so all the tests pass, which means now I can explode a number. And I don't need all of these prints. There you go, get rid of that one, get rid of that one. That's the only ones we have to worry about. Yep, that's the only one. Okay, so we can explode a number, and we want to be able to explode it multiple times. Do we have one that tests to see if it's... So this explodes into that. This... Oh, wait, this didn't work because I have commas in here, and that it shouldn't work with commas. Why did this test pass? Unused assignments. Maybe it's overwritten. Oh! Oh. Interesting. That this even worked. There should be a break here. When we hit the start condition, we got a break. And I push it on the front, and that actually does good. But why did this... Huh. Alright, that should fix at least that error. Stringify is not being used. That's okay. I can just config test that. But we still have another error. Functions never use explode. Okay, well, we will use it. Okay. But why is this test passing is my question. It shouldn't. Oh, it isn't. It's just running an infinite loop. Yeah, I got a couple of them now running. Let's quit out of this. Quit out of this. Yeah, okay, so it isn't passing. Oh, so day 18 mod. All right, so why is this running forever? If we explode, oh, maybe this break isn't close enough? We'll say break out. I mean, I only see one loop, so it should... Right, this is the match, and this is the, right there, this break out. No. Maybe this needs to be a breakout. No. Oh, what was it? No capture. Println exploded. Put that there, and then we can just do this. No capture, like that. Oh. Let's get rid of that. Go here. It says exploded. What did I do wrong? NVim. There we go. I'm going too fast here. If I break out, then it should not explode again. Oh. I bet you it's this loop here. No. Let's sum num front. If it's a start, then break. And it should be start right away. Fixing. And done. So I bet you it's this thing that's failing. Fixing. And I don't see it done. So why is this failing? If we're rotating left, we should eventually rotate the start token to the front. I mean, here it's getting pushed back. We know it's a start token because we check here. Unless there's something I'm doing wrong with this. When I say pop back, oh, look at that. If I don't want to remove the thing from the thing. I just want to say num push front next and break. So that's the difference between this one and this one. Okay, man. Let's try this. There we go. All right, now it failed. And it failed for the right reason because I have the commas. Okay. All right, change the commas to spaces and insert space here. And then this should test and pass, and it does. And process exited. That's what I was missing the first time. All right, so we can explode things now. That's wonderful. Let's test splits. Well, first we have to write it. Let's write splits. So we're going to use this as our test input for the split because then it's going to split. Test fn split 1. I don't need this print line anymore. And I'm just going to say assert split like that. And then I'm going to say assert equals stringify. This is going to be this, but all the spaces are going to, all the commas are going to be spaces. And all numbers will have a space in front of them. Like that. Yeah. Oh, no. Oops. After split, this is what we want to test. We want to check to see this. And then, okay. This here, and this here. Okay. And of course this won't work because split doesn't exist, so we have to write split. Num is going to take, I've already forgotten what type it is. Snail num. And it's also going to return a boolean to say whether or not splitting occurred. Boot. Let mot split is false. And we're going to return split. There, now I can't forget those. Okay, so what does splitting consist of? We have to do the same kind of loop, right? We want to check this to make sure that we're starting with the valid list. And we don't need to keep track of nesting anymore. So all we need to do is loop. In the last assert, you left a comma at the end. I did. Thank you very much. Oops, like that. Okay. Let's do the same thing. We grab the token, num hop front, unwrap, match token. If it's a number, then we want to see, and what we're doing is we're checking to see if it's greater than 9. Any number that's 10 or greater. So if n is greater than 9, and we're going to do, I forgot what we need to do. Oh, well, here it is. The left of the pair should be regular number divided by 2 rounded down, and the right should be regular number divided by 2 rounded up. Okay, so we're going to say left is n divided by 2. That's going to automatically round it down. If I put an equal sign in there, right is just going to be left, n minus left. All right, and then all we need to do is we're going to add a new pair. So we need a left bracket, a left number, a right number, and a right bracket, and then we're done. Right, because we only want to do a split once, and we don't check for any more splits. Right, that was this whole paragraph here, which I've lost. At most, one action applies. A split produces a pair that meets explode criteria, then we explode before we do anything else. So we don't want to try splitting again, we want to explode again. Let's see. So if we want to do a split, we want to do push at B. Num dot push back a left right. We want to left the left number push back num left push back num right, and then num push back a right bracket, and then we want to break. If we find anything else, if we find the end, then we want to push that onto the front. And break. And then anything else, which are left and right brackets, we just want to just push it back. And don't break, because we want to keep looking for a number. And then we want to do this thing again, where we reset the number. We don't need the fixing, we don't need the done. And we're going to duplicate this code here. And then we're going to return split, which we forgot to set. Split equals true. Okay, so does that check? Wow. Wow, that checked first try. Okay, let's run the test and see if split 1 works. Or if that ends up in an infinite loop. It failed. It failed here. It's saying it wasn't able to split the number. Okay. Well, I mean, that should be easy to figure out why. Pop front unwrap. If it's a number and is greater than 9, then we do the split. We set split is true and hit break. I mean, I don't see what's I don't see what's wrong. But clearly we went through here and split never found a split. So let's see if we can just print this out. Found number. Oops, got double test window now. I found number 1. It didn't find any 13. It should have found 0, 7, 4, 15, 0, 13, 1, 1. Huh. That is weird. Let me print this out. stringify num and see what it looks like. Yeah, 07415 Oh, I know why. I see why. It's because my parser doesn't handle multi-digit numbers. So I can't test that directly like that. All right, let's fix the parser. That's going to make things a little more complicated, but it'll make it easier to test, right? So it's worth doing. Let's say, because now we have to check after, when we find this, we have to say, was there a number? If this, we have to say, was there a number? You know what I can do? I can cheat. There. Now I can get the numbers at least 10 through 16, which is all we need for this. So this becomes F. This becomes D. That might be a 13. Let's find out. Oh, it doesn't like that. Oh, comma. Okay. All right. Okay, now we got the 15 and the 13. This is weird. Why did this happen? Why did that happen? All right, I can see a couple of mistakes I made. These commas don't get commified. All right, so that's one mistake, but it looks like we have open, 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 and then close, close. So it looks like I must have ruined the thing. Is this is right? So left, and then the left number, the right number, and then the right bracket. Shrishak says, can't we do a 0 to 100 and use a parse function? Oh, yeah, that's a good point. Too late now. Sorry. Okay, so what got messed up here? We should be able to stringify this after. Once we hit the number n, let's just print out the stringification of this. Q looks like this. Hopefully I can do that. Not a function. Really? Oh, because I did that. Okay. So Q looks like 0, 13. Yeah, so we got to this point here. 0, 13. Oh, wait. Really? Okay, yeah, I missed something, didn't I? Because the Q has the 0, the bracket 0, 13 bracket, and we just found a number. After found number 15. Found number 15. We shouldn't find 15 first. We should find 13 first. What am I doing? Oh, yeah, okay, 15 first. And then it looks like 0. Okay, so that's good. Oh, I'm not pushing the numbers back. Oh, that's dumb. At least it's an easy mistake to fix, right? Oops. If n is not greater than 9, we need to say num push back T. Okay. Wow, okay, so that was the only bug there. Very good. So now we have a splitter and we have an exploder. So what we need to do now is have a processor which does all the explosions and splits until it comes up with the final answer. So I'm going to write a little function process num snail num, and it doesn't have to return anything. It can say loop if explode, while explode num. We just keep doing that, and then say if not split num num break. Right? That's all we need to do. So we keep exploding while we can explode. If we don't explode, then we try to split. If we don't split, then we end. But if we did split, then we'll go back and look at an explosion again. Oops, I left off the brackets, the braces. I think that's all we need to do. And we can't bar that as mutable. Why not? Oh, do we just need to do this? Yep, okay, that was the problem there. Then let's write a test which does, oh, this is addition. We haven't even gotten to addition yet. We haven't even gotten to addition. Do we have an example of a number that needs multiple explodes? Actually, what we can do is we can just add this up directly to test our process. And process 1, and it's going to be let mod. Oh, come on. Num is convert of this, and we're going to change this so it's going to be a comma there, a close there, and an open there. And then we will say we don't need to print line this anymore. We'll just say process num. And then we're going to say assert EQ, string define num is going to be equal to the start marker, and then this. Like that. So that goes that gets a space, that gets collapsed, space, space, collapse, space, space, collapse, and space, and space. I'm going to run it here in case it's an infinite loop again. Okay, so I think we have something that works as far as exploding and splitting. Now we just need to do the adding. So adding should be pretty simple. So if we have an add num1 to num2. It won't return anything, right? Because we're gonna just modify num1, the left-hand side, directly. I think that would be the easiest way to do it. What do we need to do? We need to be able to start off. Oh, we need to make sure that they both have start markers, right? So let m1 equals. Let's call this left-hand side and right-hand side. Street Shack says you may want to implement add trait so you can num. Oh, that would be fun. That would be fun. Let me get it working first, and then we can play with that. But yeah, I like that idea a lot. So let's pop off the left-hand side dot pop front dot unwrap. If m1 is not equal to talk start panic adding LHS invalid string, invalid number. Sure. And then we do the same thing for the second marker. I guess we can just reuse those and just say right-hand side. Shadowing is fun. Okay, so now that we've popped the start off each, we want to actually... We want to, for the left-hand side, we want to push front left bracket. We also want to push the marker back on, which we conveniently have in M1. And then we want to say LHS, I think, Rust, Beck, Deck, append. I think you can just do append. Moves all the elements of other onto self, leaving other empty. Perfect. Append right-hand side. And then we want to LHS push back, talk right. And I think that adds 2 numbers. I think that adds 2 numbers. So let's do that. Let's test that. Test. Add. I keep putting 1s here because I expect to add more tests for it, but then I don't have the energy to add tests for it. So, oh well. Let mut left-hand side is equal to convert of this. There we go. I knew the triple click works. Let mut right-hand side is equal to convert of the other, which is just 1, 1. I'll type that in by hand. Process. Oh no, we want to say add. Mut left-hand side. Mut right-hand side. And then process. And then the same assert equals. LHS. And it failed. What did I do wrong? Oh, pop front is a function. Enjoy copy pasting code as you get the error multiple times. And we're still getting 6 checks. Internet Bird, thank you very much for the follow. Stringify, explode, split. Oh, because we're not calling it in we haven't written the actual code yet. So this does this test. Wow. Okay, so add works. I think we're really, really close. Let's see if we can get this working with our test code then, because all we need to do now, we've converted all the numbers here. And now we want to add 1 at a time. So we have nums. So we say, oh, this is just a vec. Yeah, I'm thinking, okay, I want to grab the first one off of it. Let's just make it a vec deck again, because those are fun. And I can just say let mut result is equal to nums.pop front, unwrap. And now what we'll do is say while nums is empty, we're going to pop let mut next num is nums.pop front, unwrap, and then we want to add it. So add mut results to mut next num, and then we want to process mut results. Oh, we're not even close to done. I forgot. We need to figure out this magnitude thing. Well, at least we can print out the final sum and see if we got that right. Final sum is going to be stringify results. And if that's wrong, then we have some digging to do. So cargo run. Argument never used. Now I have to use pushback, right? Okay. So let's run that. Well, that failed. We have, instead of 66767770, we have 8777867707. So that didn't work at all. And we got a ton of output to show us where we failed. So you know what we can do is print one at a time. And see where we go wrong. Added to this. Oh, it's just this. String fi result. And then processed that. And then final sum we don't need because we got processed right there. And now I want to get rid of all the other printlns because I don't want all that output. We don't need to say we exploded or found a number or what the queue looks like. So it's just these two. Okay, good. So let's run that and see where it failed. Oh, argument never used. What? Oh. There. Wow. That error message was unhelpful. All right, so now we have this. And this is a slightly larger example. We're adding 4500452695 to this number, 737436888. Okay, so that worked. And after we processed, we got this, which is 4054776087777950. Okay, so that step worked. Next step is this guy. And that looks correct. Next step is this guy. 7077777887. That looks correct. Oh, wait. That's right. We got the right answer. Then what happened? Let me do that. Did I just mess up the printing? Oh, I'm running a test. Stop that. Run. Okay. Yeah. Oh, that's all right. That's all correct. Oh. Okay, this is a different test. All right, well, let's test this one. Inputs test 2, day 18. Let's see if this comes up with the right answer. Test 1, change to 2. Okay, I think we're getting close. We just have to write the magnitude thing. Let's see if this 667677. Okay, all right. Good. I was wondering what could we have gotten wrong? If we got the splitting right and the exploding right, what could go wrong? All right, I don't like all this redundant code, but I'm going to live with it for now. What I want to do now is figure out this magnitude thing. So now we got to write a test for magnitudes. Magnitude, and I'm going to put a 1 there just because I'm being consistent now, even though I'm not going to add any more. Actually, we can add all of these guys, right? Let's do those and make them all separate tests. Actually, what I can do is here, let num equals convert this, and then just do that. And we don't need becomes. There. And now each one of these is going to get its own magnitude and its own closing brace. And I should have kept the I should have kept these numbers. Oh well. So I'm just going to do one test for now because I don't want to go nuts. And I want to measure the magnitude of these things. Assert EQ mag of num is going to be 143. And now we need to write magnitude. is num is a snail num, and it's going to return. Is this going to get too big? I'll just do U64 just to be on the safe side. Now, how do we measure this? What we need to do is 3 times the left side plus 2 times the right side, and then that just bubbles up. So we want to loop over everything and just keep popping. And then when we hit a number, or if we hit a pair, then we want to convert it. So, okay, the first thing we want to do is add that check for the start of the string. Make sure it starts with a start. And then we'll push it back like we did right here. So then we're going to loop over the whole thing. Get our token, num.pop front, unwrap. And what are we going to do? Match T. I'm thinking ahead already because we have to accumulate data. If it's a left or a right bracket, then it's clearly not a number. Then what we're going to do is we're going to just say num.pushback of the token. And we're going to keep track of whether or not we saw a number, because we want to see 2 numbers in a row. And so then this just gets was num is false. If it's a number, then we want to say, was the previous one a number? And if so, we can actually grab it from the back. So we can say if let toke num the left-hand side, because we just popped the right-hand side, num.pop back unwrap. So now we've popped that. We can find a new number. So the new number that's going to replace this is 3 times, I don't want to use new, mag, sure, is equal to a new number, talk num of 3 times the left-hand side plus 2 times the number we just found. And that, so so if we're imagine the queue, we just push the left, we push the left, we push the 1, and we set a flag. We haven't gotten to that code yet. And then we pop the 2. So now we pop the 1, and we want to get this bracket off. And we also want to get this bracket off. So we want to say num.pop back to remove the left bracket. We want to say num.pop front to remove, let's line these up, the right bracket. And now we're going to say num.pushback the magnitude that we just calculated. Right, and then else, it's a number, but we didn't see another number. This could be the left-hand side, but we don't know yet. So we'll just set was num to true, and num.push back the token we just grabbed. If we hit the marker, we've processed the whole thing. We want to put it back in the front. And break. Okay, and we want to do this. We want to keep doing this until we've run out of numbers, right? We have this loop here, but I think we need actually to go further into the loop. I think we need to say while here, while num.len, it's going to be the start marker. I'm going to say 4, right? Because it's going to be start, left, answer, which is going to be the magnitude we calculated, and then right. That's what's going to be on there when we're all done. Oh, I already have that. So that's that while. And this is the loop. Okay, I got it all on one screen. So this will calculate the magnitude, but this break only breaks out of the inner loop. That's fine because do we want to reset the marker? Oh yeah, we only break when we hit the marker. And then we start again. Okay, I think this might do the trick. And what we want to return then actually what I'm going to do is I'm just going to say println because I want to see what it looks like after we did all that. Stringify num. And that way we'll know how to grab the value. So the magnitude test should fail because I'm going to return 0. There. What did I do? Oh, I forgot the star. Okay. And marker, start. I keep saying marker, but I wrote start. So what's wrong here? Oh, yeah, I'm mutating the list, aren't I? As I magnify it. Okay. Or magnitude it. All right, let's run the test now. And I do need to pass in mut here. I'm going to do this again from the command line because I don't know if I hit an infinite loop. Really? Yeah, infinite loop. Okay, we can fix this. While numlen is greater than 4, so we're popping back, popping in front, pushing the magnitude. Is there anything else we need to do? Oh, I'm not clearing out this was num. I wonder if that's important. Let's run a quick cargo test in case that was the bug. And it was not. I didn't think so, but it couldn't hurt to try. So let's, after we did this, let's print this out. I'm gonna have to just look at the first few, otherwise it's gonna be oh, we're not getting anything. Interesting. So we're never hitting a number? And what I'm going to do is I'm going to just put this here so I can just run it directly in mag. And this way I can say cargo run head 20, I guess. Oops. Where's the one that's missing? Here. So it's finding numbers. I should say that, okay, processing converted to this, and it's just left-hand side number is the right-hand side, and then the magnitude is the magnitude. Okay. Oh. Okay. So before I print it, I gotta print it before I do it. Okay. Okay, it converted 66 to number 30. And then 76? Wait a minute. Did I get the wrong? Oh, no, this is the final one. Okay. I'm not even looking at the test. Let me look at the test now. Now I got some output. No, I didn't want to do that because I can't hit Control C. There. Oh, that's interesting. That's not printing anything at all. It's like it's not hitting. Oh, I forgot the no capture. There we are. Yeah, that's what I thought was going to happen. It was a. Well, that's interesting. It reduced it down pretty far, but it's got this. It's not able to handle this one here. So we went 1, 2, which converted to 3 plus 4. Then we saw this pair here, right? It should have been that, like, so 9 plus 8. So that's 17. That's where the 17 is coming from. But it should have been able to find the two numbers together. Let's just do this. First num t. And hopefully this break is actually breaking out of the inner loop. Not the outer. Well, it's not breaking out of the outer loop. Because it's spinning infinitely. Oh. Yeah, no, this is a number. And this has to be the number. It has to be a number, right? Does it? Yeah, because the previous one was a number, because we set that flag. Okay, so I'm printing out this now. Let's see if that helps us at all. Converted 1, 2 to 7. 3 times 1 is 3, plus 2 times 2 is 4, is 7. Then we got a left. Got this. First number is 3. Converted this. And I'm getting an OK here. We're printing out this stringify. reached start. Okay. Let's do 50 now. So reach start with this, and now this should reduce. Oh! Oh, I see it. It was this error checking I added in here to make sure the string started with a start. It moves the start to the back so we can actually process the thing. All right, I'm going to get rid of these prints because I'm going to assume that was the bug. And now cargo check, no capture. It failed, but it printed 143, which is great. That's exactly the answer we want. So there's a marker and then a 143. So it should be the last thing. So what we should do is return num.popback unwrap as U64. Oh, that's not going to work, is it? I just realized. So I'm doing everything with U8s. Okay, we're going to change that to U64. And that's going to cause these things to fail, but that's all right. We can fix that. What did I forget here? This. And it doesn't like this. Expression can only be used to convert. Well, it's already U64, so we don't care. And what kind does it think it is? It found a token. Oh! I can't use unwrap on token type. Otherwise, we're going to return 0 and fail. That's probably a better way to do that. Not some answer, talk answer. No. There. Okay, run the test. All the tests pass. Should we test all the other magnitudes while we're here? Why not? So this, and this. I'll separate these guys out. I'll change all my 1s, 2, 3, 4, and 5. And then we could just change these numbers here. 1384, 445, 791, 1137, and 3488. Just to make sure all these pass. Test. And it doesn't. Oh, did I forget one of the ones? I did. I'll call this one 0. Oh, and I forgot to put test in front of them. There we go. All the magnitudes pass. Good. Okay, so I think we're ready. I think if we just run this now, we'll get the test output. 4140. That equals 4140. So that's good news. Let's do our real input. And I'm going to change this so we don't have to print this out. I'm going to change this. Let's go. I agree, Shrishak. Day 18, part 1. Can only imagine what part 2 is going to be. We do have 2 warnings though. Oh, because I'm not calling stringify. So I should make that a test thing again. So I got 3051. It's a number in the same kind of general range. I just want to double check. I changed it. Yeah, I changed this back to my test input. Because it does feel a little small to me. I would have thought, yeah. So this is the full thing. All right. Well, let's see. That's the right answer. Okay, good. So that took an hour and 46 minutes. Wow, this was a puzzle and a half, huh? Now I don't want to commit the main yet because I changed main. Actually, let's change it back. Because I have it running the current day. Let's change it back. Cargo run 18. Yeah, okay, so that's good. Git and source and inputs. Git commit -m day 18 part 1. All right, so I think we're ready for part 2. You notice a second question on the back of the homework's assignment. What is the largest magnitude you can get from adding only 2 of the snailfish numbers? Note that snailfish addition is not commutative. X plus y is not equal to y plus x. Okay. Considering the last example homework in the assignment, the largest magnitude of the sum of any 2 snailfish numbers is 3993. Okay, I think that should be straightforward. We have all the snailfish numbers. We can get the magnitude of each one. So I'm going to actually have to read them again. Right? Because I just mutated them all to get the result here. But I think what we can do, I think all we need to do is say nums equals vec new or vec dec new. Read them back in again or reconvert them. Oh, no. We don't have to do that. We can be smarter. We can just convert them here. Let mut mags vec of u64. And I don't, maybe I can clone it. Let's see if I can clone them. Let c equals convert l. C a clone. And then what I'll do is say mags.push mag of got a mutatable. C. Can I do that and then just get all the magnitudes that way? And then sort them and then add the last 2. Okay, copy clone. And then all we need to do is sort the mags. And then just grab the, it's a sum of any. I was thinking, we just need to grab the magnitudes. But no, we have to add up all the pairs. We have to add up all the pairs of magnitudes. Okay, so it's not as simple as I thought it would be. What's the easiest way to approach this? We have them all. Is copy required? If you do, I think if you do clone, you need copy. I think that's one of the rules of. Oh no, you're right. Maybe it's if you have copy, you need clone. Maybe it's the other way around. But in any case, we're not going to do that because. Okay, so we have a list of all our numbers. We want to be able to add up all the pairs of numbers. And then compute the magnitude of all of them. All right. So I think the easiest thing to do is just lots and lots of cloning. We have to compare each to each, right? So it's 0.nums.len. This should be I in, and for j in I 0 dot dot nums dot len. If I equals j, then continue. Otherwise, what we want to do is let next, no, we're going to do left-hand side equals nums dot of I dot clone. Let right-hand side, and this got to be mutatable because we're going to add them first, nums of j dot clone. We're going to say add left-hand side to the right-hand side. Oh. Come on. Mut left-hand side to mut right-hand side. We're going to process the left-hand side. Then we're going to find the magnitude. I call it mag, right? Yeah. Okay, and then we're going to just save the highest. And 0. And down here, we'll just say, you don't even have to grab that, we'll just say highest equals highest max this. And that's part 2. Input. So let's change this to test 2. I think this was test 2, right? Day 18. 058. Yeah, okay. So test 2 doesn't work because I forgot to put the J. Oh, and now we don't have clone. Clone. There we go. Still 3 warnings that we need to clean up. Oh, I ran tests. I want to run the run. And it panicked. Len is 18, but the index is 18 on line 70. On line 70? 70. What? I'm very confused. Oh, I know why. There we go. Now I got 3993. Okay, that works. That works. Yeah, I can't run it from inside because the run automatically assumes it's the current day, and the current day is 19, and 19 doesn't exist. I guess I can fix that just by repeating this guy. So now source day 18 mod test 2 changes to input. Let's see the moment of truth. Oh, I hit test again. Run. It's not fast, but it came up with an answer, 4812. And that's the right answer. Nice. Okay, so I think we're good with this. I do want to get day 19 done before I do any cleanup work. I might save the cleanup for tomorrow's stream. Because who knows how long or how hard day 19 is. All right, so we got a bunch of repeated code. We got a bunch of issues. We have this stringify function, which I'm going to modify and then to be a test-only thing. Oops, like this. And then there was a mut convert here. I just want to change that. Let's see, like this, and that should clean that up. And maybe the bubble sort is taking too much. Yeah, the problem is you have to compare every, right? Because it says, turn to my advent calendar, 18. It says it's not commutative, right? If x plus y is not equal to y plus x, so you have to check both directions. It's not really a bubble sort, but it has the O of n squared speed. So, oh, thank you, Shrishak. Shrishak says congratulations. Okay. Let's check in with Clippy actually before we do anything else. Clippy says I don't need to use sort. I can use sort unstable. Sure. Oh, why am I even doing that? I don't need to sort them anymore. But there's still an issue. Oh, because now I'm not using mags. There we go. Okay, git add source. That was it, right? Git commit day 18 part 2. Git push. Okay,